Hi everyone. Welcome back to our video lectures on numerical analysis. In the previous videos, we were discussing about interpolation. So we have discussed what is interpolation and the theory which supports our procedure. Let us quickly recall the interpolation and some of the methods of interpolation before going to the new method. Suppose the values of a function y equal to f of x are given as x naught y naught up to xn yn. Then we will use the values of the function at x naught, x1 up to xn for finding an approximate polynomial for the function f of x. For that approximation, we were using Newton's formulae for interpolation and Lagrange's interpolation formula. One can recall that Newton's formulae for interpolation, either it is a backward formula or forward formula, it was used when the points x0, x1 up to xn were equally spaced. The points are not equally spaced, we were using Lagrange's interpolation formula. The disadvantage for Lagrange's interpolation formula is as follows. Suppose x0, y0, x1, y1 up to xk, yk are given, and we use Lagrange's interpolation formula to find a polynomial of degree k plus 1. Later we find that there are some more values are available, then you have to modify the Lagrange's interpolation formula in such a way that you have to start from the beginning. You have to rework every term of this one. Here we provide another formula called Newton's General Interpolation formula, which is defined using divided differences. So we will begin with what is divided differences and how to calculate divided differences. Let x0, y0, x1, y1 up to xn, yn be given points. We define the divided differences as follows. The divided differences of x0, x1 is equal to y1 minus y0 divided by x1 minus x0. You can notice that interchanging this order, that is, if somebody is writing y0 minus y1 and x0 minus x1, the sign will not change, the value will not change. But anyway, we will be using x0, x1 as y1 minus y0 divided by x1 minus x0. This is the first order divided difference. The second order divided difference x0, x1, x2 will be obtained by x1, x2 minus x0, x1. That is divided difference of x1, x2 minus x0 divided difference of x0, x1 divided by x2 minus x0. The divided difference of x0, x1, x2, x3 is x1 divided difference of x1, x2, x3 minus divided difference of x0, x1, x2 divided by x3 minus x0. Like this, you can find the divided difference up to xn. Now let us illustrate the divided differences through a problem. Given values 1, 2, 2, 5, 3, 10 and 526 of a function, we have to find the divided difference. We will do it step by step. In the step 1, we will make a table keeping x0, x1, x2, x3 and corresponding values of y0, y1, y2, y3 in the table. We want to find the first divided difference, that is divided difference of x0, x1, x1, x2 and x2, x3. So as per the formula, divided difference of x0, x1 will be y1 minus y0 divided by x1 minus x0, which is equal to 3. Divided difference of x1, x2 will be 5. Divided difference of x2, x3 will be 8. Now we will rewrite the table as follows. Using the table, we will start calculating the second divided difference, that is divided difference of x0, x1, x2 as divided difference of x1, x2 minus x0, x1 divided by x2 minus x0, which is 1, and divided difference of x1, x2, x3 is 3 by 2. Now we can modify our table as above and calculate the next divided difference x0, x1, x2, x3 as 1 by 8. So the final table looks like this. The first column says the numbering, the second column is x value, third column is y value. This is first divided difference, next column is second divided difference, and this is the third divided difference. Now using divided difference, we will calculate the general interpolation formula by Newton. So given the values of a function y equal to f of x as x0, y0, x1, y1, etc., xn, yn, and the first divided difference of x0, if you calculate, it will be y minus y0 divided by x minus x0. With a rearrangement, you can write y as y0 plus x minus x0 times divided difference of x0. The second divided difference x0 x1 will be divided difference of x0 minus x0 x1 divided by x minus x1. Rearranging this, we will get divided difference of x0 is divided difference of x0 x1 plus x minus x1 times divided difference of x0 x1. We already know that y is equal to y0 plus x minus x0 divided difference of x0. Replacing this x0 with divided difference of x0 x1 plus x minus x1 x0 x1. So rearranging, we will get y equal to y0 plus x minus x0 times divided difference of x0 x1 plus x minus x0 times x minus x1 divided difference of x0 x1. Now using this one, we can go for the general interpolation formula as y equal to y0 plus x minus x0 times x0 x1 plus x minus x0 x minus x1 times divided difference of three terms x0 x1 x2 plus x minus x0 x minus x1 x minus x2 times divided difference of four terms, that is x0 x1 x2 x3, up to x minus x0 x minus xn times x0 up to xn. Now let us see a problem which we will be using Newton's general interpolation formula. Find the value of the function at 301 from the following table. This is a problem which we already discussed in Lagrange's interpolation formula, but we will see what is the change we are going to happen here. We will take the divided difference table. First column is number, second column is x values, third column is y value, the first difference, second difference, and third difference. Third difference is not going to give you a new thing, so we will keep this only first difference and second difference only. Keeping these values, we will find y equal to y0, x minus x0, x0 x1 plus x minus x0, x minus x1, x0 x1 x2. Continuing this one and substituting y0 is equal to 2.4771 x minus 300 times 0.00145 x minus 300 x minus 304 times minus 0.0001 plus 0. So f of 301 will be 2.47858. So if you convert to 4 digits, round off to 4 digits, it will be the same value of what we got in Lagrange's interpolation. But what was the advantage for this one is, suppose one more set of values are given, that is, if you are given the value x3, y3, by just adding one more term to this one, you will get the new polynomial for y. We just last term only we have to modify. Last term we have to modify and one more term we have to add. So that is the advantage for Newton's general interpolation formula. Try these problems yourself.